So today we are going to start with chemical kinetics. What is chemical kinetics? Chemical kinetics deal with variation in concentration of reactant and product with respect to time. Okay, so concentration of product reactant. Okay, then concentration with respect to time. It talks about how much concentration of product and reactant has been changed. So let's talk about the types of the reaction. First talk about the types of the reaction. Okay, so the type of the reaction on the basis of time requirement of the reaction. Okay, on the basis of time requirement of the reaction. So let's talk about very basic thing. How many types of the reaction we have as according to the time required for the reaction. Okay, so first of all we have the slow reaction. What are the slow reaction? That takes very long time for appreciable change in concentration or mole of substance. Okay, which takes time in change of concentration. Okay, so if we draw a curve between reactant versus time, so the concentration changes with very less. Okay, concentration of reactant you will find with the time it is changing very less. So what are the reactions? What these are the reaction? Okay, like examples are 2 hydrogen plus oxygen gives H2O, 2H2O in liquid. Okay, so these are the example of slow reaction. You can also tell the rusting of iron. Okay, conversion of carbon graphite into carbon diamond. These all are the examples of slow reaction. Now what are the fast reaction? Fast reaction are those reaction which takes fraction of second for completion of the reaction. Takes fraction of seconds for completing the reaction. Okay, if we draw a curve between reactant versus time, it is very steep. Okay, what are the examples? Like all the ionic reaction, all ionic reaction and all acid and basis reaction. All ionic reaction, acid and basis reaction are an example of fast reaction. Now let's come to the moderate reaction. What are the moderate reaction? Okay, neither very fast nor very slow. Okay, it takes second, minutes, hour for appreciable change in the concentration of reactant into product. Okay, these are neither very fast nor very slow. Okay, so actually they are not these are not very fast, not very slow. We prefer to study like we prefer to study this type of reaction. Okay, so if we draw the concentration of reactant versus time, it gives this type of curve. Okay, so it takes it is not very fast. We can see how fast it is changing. Like example, H2 plus Cl2 gives 2 HCl. Okay, so these are not very fast reaction nor very slow reaction. So we generally prefer to study this type of reaction in our chemical kinetics. If we try to study the slow reactions are very long time taking, so it doesn't make any sense. The fast reaction are very less time taking, it also doesn't make any sense. And the moderate reaction, they are not very fast reaction, they are not very slow reactions. So we can study these type of reactions to calculate the time. Okay, if the reaction is completing in 10 seconds, we can calculate how much reaction has been completed through 2 seconds, 3 seconds. Okay, all the reaction we can take this. Okay, so now just say type of the reaction according to rate of dissociation and rate of association. Now what is rate of dissociation and rate of association? Like A is forming B. Okay, so rate of dissociation and rate of association. What is rate of dissociation? Minus dA by dt. This is a rate of dissociation. And what is rate of appearance? Okay, not rate of association, it is rate of appearance. So rate of appearance of B is dB by dt. Okay, this is rate of disappearance and rate of appearance. So let's talk about type of the rate of disappearance and rate of appearance. First is average rate. So what is average rate? Average rate. Let's take an example. Reaction A is giving B. So what is the average rate? So average rate is average rate of dissociation of A equals to minus delta A by delta T. Okay, means concentration A final minus A initial divided by T final minus T initial. Okay, that is a positive value actually. So this is the average rate of dissociation of A. Average rate of dissociation of B. Okay, average rate of disappearance. Average rate of appearance of B is minus dB by delta B by delta T. It is B final minus B initial by T final minus T initial. It is again a positive value. Okay, so here we don't use the negative sign, we have here positive sign because it is the rate of appearance. Okay, that is dB by dt. So if we see a curve, this type of curve, if a reaction is going like this, if we talk about the concentration of product in A, then A, this is T. At time A it is T1, it is A1. At time T2 it is A2. This is A1, this is A2. Okay, so this is the average rate of dissociation, that is minus delta A by delta T. Average rate. Okay, we are saying at the time T1 the concentration was A1, and the time T2 the concentration was A2. Okay, now it is the average. Now if we talk about instantaneous rate of the reaction, so if we draw a curve, concentration of A versus time, it's going same like this. Now as we know that as A2 approaches A1, it becomes a point and we draw a slope. Okay, it becomes a point and we draw a slope over it. So when we are drawing a slope, the rate is minus dA by dt. It is instantaneous rate. Okay, this is instantaneous rate of disappearance. Okay, you got what is the difference is here we are talking about average rate and here we are talking about the rate at a particular instance. Okay, this is the difference between average rate and instantaneous rate. Now if we see a rate of the reaction, now what is rate of the reaction? What is rate of the reaction? So if we take an example, 2A plus 3B gives 4C. So rate of the reaction is minus 1 by 2 dA by dt equals to minus 1 by 3 dB by dt equals to 1 by 4 dC by dt. So it is the rate of the reaction, either 1 by 2 dV by dt minus 1 by 3 dV by dC or 1 by 4 dC by dt. Okay, so this is rate of the reaction. If we know the concentration of change of A, if we know how the concentration of B is changing, if we know how the concentration of C is changing, then we can say what is the rate of the reaction either with the help of A, with the help of B, with the help of C. So the rate of the reaction we generally defined as it is equals to rate of disappearance of A divided by the stoichiometric coefficient A. If we see a reaction AA plus BB giving CC, so here rate of disappearance of P divided by B, it is rate of appearance of C divided by stoichiometric coefficient C. Okay, so that's how we define the rate of the reaction. Now see, this is the rate of disappearance of A. Okay, rate of disappearance of B, rate of disappearance C, and they are generally taken at the mole per liter per unit time. Unit we should be know what is the unit, mole per liter per unit time.